Hello, my name is Gavin Fisher and I'm an application specialist from FormFactor. Today I'm going to show you the various hardware components that are required to put together an autonomous RF measurement assistance solution, and in this case on a Summit 200 probe station. So what you see on the table in front of us are the components that we require to convert the station for full autonomous testing up to 120 gigahertz. Probably I'll start with the main event, which is the RPP504 positioner. You can see the positioner here. So with the RPP504 positioner, we have three motorized axes. We have Z and X and Y over here. The positioner has an arm on it, which allows us to mount the RF probe down here and the frequency extender up here. This bracket that you see here will be used to mount onto the underside of the frequency extender, and we'll slide it in place over the top like this, and we will lock it using these clamps right here. The positioner base has a recess which is designed to take these V-ways. So these will bolt onto the platen and enable us to clamp this positioner onto the platen. So the positioner has a cable that you can see here. This cable will attach to, in the case of this probe station here, the Summit 200, or in the case of a CM300, will attach to an MPX control box. In the case of an Elite or a Summit 12K or an S300, it'll connect to an ECX box. Both serve the same function, controlling the Z, the X and the Y axes of this motorized positioner. The positioner has a control here, which you can see, which will adjust the roll angle of the probe mount here. We need that in order to make sure that all the probe tips are correctly touching the wafer evenly. So, this positioner will be used with a variety of probe stations, but these probe stations have the capability of changing in temperature. This is fine when we reach higher temperatures, but lower temperatures is more tricky. Also, we may have devices which don't want light ingress, so because of this we want to have a sealed environment. The sealed environment also allows us to have dry gas inside, which prevents moisture forming on the wafer and ultimately freezing. So in order to have a sealed environment, you'll see in a moment the top hat, but the top hat has seals which attach between it and the positioner. Now it's important that these seals are pliable and can be easily moved. This design we came up with specifically for this need because we didn't want any stiction. So as you can see, we have a cloth bellows which allows very easy movement, and there's no stiction in there. So in order to do this, we need to attach this section here, which we call a boot, to the positioner. So what I'm going to do is I'm going to feed, if you see through here this this orifice here, I'm going to, with a clearance on the bottom for the underside of the shaft, I'm just going to feed that through here. Goes onto the positioner. You can see these two screws here. I'll show you the other one here. And that way this is ready to be sealed in advance to the top hat. So the part that I have in my hand here is the top hat assembly. This is an RF top hat which is designed specifically for this need. We use this for a variety of applications. We developed it originally with this N5291A that we show here today. We now use this for millimeter wave applications going up to WR2. It allows us to have a sealed environment which is free from light ingress and free from ingress of moist air. Essentially it's a piece of metal which it envelops the whole aperture inside the top of the platen assembly of the prober. You'll see around here we have some blanking plates. Typically we would have all of them blanked off with something either blanked off or with this boot assembly in place. On the front of it, at the moment, we have a window which lets us keep the dry gas inside, but we also have a cover which we can cover that. You saw me earlier fit the boot to the positioner. This just shows you putting the boot onto the top hat assembly. Effectively it goes over the top. You'd have your positioner arm out there. And we seal it tightly against the rubber seals which act as a gasket. This then allows us to move our positioner in a sealed way without any resistance to movement. So before we put any positioners on the Summit 200 probe station here, we want to make a modification on the platen by removal of the top hat assembly. The top hat assembly you see here is the one that comes with the station when you buy it. In this case the station is an AttoGuard version, and so it has AttoGuard layers in the platen for good DC performance. We're going to remove that in order to fit our four-sided RF top hat in its place. It's a very quick swap out, very quick and easy to do. We just take a 3mm Allen wrench, undo the 4 M4 screws, which are basically at the free, well in fact, I'm not sure what the position that is, these ones. I remove those screws, and if I want to get a bit more space, I can remove the objective from the machine like that. Make sure that I don't catch it on the way out. Make sure these are in. And I can lift this like so, just straight out the machine. And I find somewhere nice and soft to put it down on, so it's not damaged anyway. So now we're going to replace it with the four-sided RF top hat. We'll install it with the window at the front of the machine. And it's very simple and straightforward to install. So prior to installing the positioners, we'll open all the top hat up, just so it gets the ability to get the probe just dropped straight over the top of here. It's an awful lot easier to do. It is actually possible to push that straight in, but it might be a bit easier just to take these off, and it allows you to see the innards of the top hat assembly. These simply are held in place by 2 screws. Take off the top, and you can see it's now completely open, and we can drop the positioner straight over the top into here. So our 2 rails, which we're going to use to hold the positioners on with, we bolt to the platen. We bolt them just right here. The screws are M3 screws, and we use a 2.5mm Allen wrench to do so. Just going to tighten that up. Just give it a little wiggle, make sure it's pushed slightly biased to one side. And that's our rail in position. I'm going to drop my positioner straight over the top of it. In this case, before I mount the positioner, I make sure that the mounting screw is loose. If you have difficulty getting it on, this can be pulled back to give a little bit more clearance. The reason why we have this part is sometimes we have very heavy components which we put on there, And what can happen is if there's a very heavy component down here, it can swing forwards. So this is like a safety mechanism. It doesn't lock it tightly, it just prevents the positioner from rocking forwards. So the other thing to note here is I've got my chuck in the low position. So there's no probe on there, but I don't want any chance of maybe if I accidentally move it, I don't want it to ground the underside of here on my chuck and potentially scratch it. So I drop the chuck so it's nice and far away from contact. I just push it so I can feel it engaging with the rail. I can watch it, make sure everything's clear, and it's good. Right now I'm not going to bolt it down, I'm just going to get it roughly in the right point. Just so I can, there's a couple of pins which this thing engages with. I don't know if you can see that right from that angle, but just inside the top hat there's 2 dowel pins which this goes onto. I'm just going to lightly place it in there just to get a rough feel for where it wants to go. In general, when you place this, if you look at the top of the rail, you'll see there's a little, if you look on the top of the rail, you will see there's a little recess just like here. The position is more or less in the right spot when the leading edge of the base is just a few millimeters shy from this point here. You'll find out in more detail when we put some probes on there and we're looking at the center holes of the chuck. That gives you a better feel for it. But you get it roughly in the right spot by putting it there. Now, once you've had it on one time, you can actually mark the platen with a little marker from some permanent marker. Don't worry, that comes off very easily with isopropyl alcohol. And that gives you a good position to put it to if you want to add and remove them more frequently. So let's do the same for the other side. Bias it slightly. I'll just move my frequency extender out the way, give me a little bit of room. When you lift it, try and lift it by the base. You don't really want all the weight to be carrying on the front. It's not too essential. Make sure the cable isn't going to snag anything. Sometimes it's useful to hold the boot assembly just so you can see what you're doing. And again, we've got it on pretty much in place. Prior to putting any weight on it, what I will do is I'll just put these screws in, just in case, most of the way in, but not tight, just enough so they can still move. Because I'm going to put my probes on there and look at the shadow of the probes to see, just to check that the position of my bases. Similarly on this side, the screw for this side is around where I'm pointing, just back here. In order to tighten this, you'll need a 5mm Allen wrench. So just move it a little bit. So I'm going to move my positioners towards the back of travel. So I know that with my position is roughly good, we should be able to put probes on there, no risk of the probes touching one another. So for these measurements, I'm going to use the modeling version of the Infinity 110 GHz probe. The reason is it gives a slightly flatter RF performance. If desired, you can instead use the A version. They both work. The tips look visually very similar to the system. But I'm going to use the AM because it has a slightly flatter performance and is more suited to modeling work. So in the case if the probe is brand new, you will have a label across here which you'll need to slit. You'll see the label on this one where it says tested, which is to say they've tested it at the factory prior to the probe being shipped, and we knew its condition was good prior to shipment. But I don't have that on this one. I'm going to open straight up. I like to have the probe in the same orientation as the mount is. So for a left-hand probe on port 1, I would have it this way around. If I was doing port 2, I'd have it this way around. I like also to make sure I've got, space. If you give yourself lots of space, if the objective is still in the machine, remove the objective. You don't want anything getting in your way. If you've got a shirt with loose sleeves, pull your sleeves up. I'm just going to remove the cap from the back of the probe and just put it to one side for a minute, only because I don't want it inadvertently dropping and falling into the box. I'm going to grip the probe. Sometimes it's an idea to tip the probe up slightly so that if you take this off and you drop it, it's going to fall backwards. It won't fall back into the box and bounce around. I've never had anything bad happen from that, but I always concern myself with that. So put that to one side, lift the probe up. There's a pin inside there, not sure if you can see on the probe mount, just inside, so that pin will engage with the center hole on the probe. So that when you put it on the mount, it can't possibly fall off. It just can't. As long as you have a good distance, and I've got a very big distance at the moment between my chuck. This is one luxury I certainly have on the Summit 200, with very large travel range of the chuck. That's in part to get the robot inside, but it also helps me very much here because I have lots of distance. I know it really would never touch my probe tip on the chuck. And I know I can just get that, put it straight inside, pivot my fingers slightly and just drop it on like that. And so it's very simple and easy to do. I'll go and get the opposite probe now. Again, same as before, make sure the box is facing it, make sure it's not going to fall down here or anything like that, nice and secure. Remove the cap, put it to one side, make sure you put it back in the box afterwards. I'm going to just get the probe, just take this off for a second. So I'll put it inside here and drop it onto the probe mount. I haven't put any screws on, I'm going to do that right now. Always be nice to the next person or nice to yourself. So when you've finished, put these parts back in the box. Do it for both of them. Box clips shut nicely like so. So I'm going to secure both the probes in place. We use a number 8-32 screw for this. It's a unified course. So we secure the probe with the short screw. Want to make sure you do have the right length of screw. If the screw is too long, it can stick underneath and it can hit the wafer, so you really don't want that. So you want to make sure you have the right one. Now, one thing I sometimes do when I do this, and it's difficult to show, is I push the probe into the back of the mount, which makes it square. There is a little bit of play in there, so you can adjust it. Likewise, if you put the probe on and you notice there is a significant angle across the probe tips, you can slacken these screws and rotate the probe in the opposite orientation until you get the rotation of the probe tips looking the same as the wafer rotation. Okay, let's do the same thing for the other side. Okay, so I'm going to secure the left-hand probe. Do the same kind of thing. I'm not sure if I can see me. Let me try and put my hands around the other way. So that's both my probes secured. Okay, so before I lock all the positioners down, I want to make sure that the probes can physically overlap. So on the wafer prober, what I'm going to do is I'm going to press the center button. That's going to move to where the center of the chuck is. So that's in the center. With platen levers up and the positioners controls are all the way up. So I'm And I'm going to go up to my old contact height, which is what I had with the wafer on earlier. So I'm pretty confident. Oh no, it's been unloaded, so it's going to take it all the way up like that, so we can see what's going on. Doesn't need to be that precise here. And with the both probes are retracted. So I'm just going to move this probe here to the point. Now, what might be a little bit difficult to see, I'm moving the positioner in to the point that the positioner is in the center position. So if you look at the base of this positioner, as I move this back, you will see that this point here is behind the raceway. If I move forwards, you'll see it's in line. That's the middle position that the positioner goes to. That's where I kind of like to operate around that region. But the positioner has a range of, let's say, I think it's ½ inch. Let's say it's 12 millimeters in total. So that'll give you ±6. So you might, if you have a long transmission line, you might have the situation that if you were trying to move one probe backwards to reach the end of the transmission line, you might have some difficulties. So what I tend to do is I tend to bias the position about halfway forwards. Not all the way, just about halfway forwards. So around there, there's about 3 millimeters approximately between the leading edge there and the position. I don't want anything to be too stretched. I don't want to be reaching the end of travel. And at that point, I'm looking for my probe tip to be approximately over the center hole. And you can see that shadow, if you look down here, if I put my platen lever down, and look at where the probe tip is, you can see that group of 2 holes there. There's a group of 5 holes in total across there. The center one will be the 3rd hole along. That means my probe right now is more or less overlooking that center hole of the chuck perfectly. So I'm really quite happy with that. And then on that basis, I'm going to just lift up slightly. I'm going to lock my staging position. There's a screw right here. And that's going to go nowhere. So I'll pull this back. And likewise, I'm going to do the same thing for the right hand one. I think we're more or less in the right spot, but this is my check. I'll move it in. If I look at my raceways, about 3 millimeters over is around there. And again, I'm more or less looking at the 3rd hole along. So I'm pretty happy with that too, which isn't bad by doing it by eye. But if I wanted to, I could slide the base of the positioner backwards and forwards. If you ever do slide the base of the positioner, do this, move the probe in Y. So if you slide it, you're not going to slide into the opposite probe. So if you see me, I can put my hands, make a little adjustment like so. Just make sure I didn't move to anywhere silly. And then I'll just lock the thing in place. Make sure you don't put any load on it because it might move a tiny bit. The screw was more or less all the way tight, but I'm just doing it the last sort of half turn, which will lock it onto the platen really tightly. So those are my 2 positioners locked down now. I want to do that before I start doing any manipulation and, you know, pushing things, because the last thing I want to do is to push hard and find an unexpected movement. So, RF cable. This RF cable is a 10 centimeter version. We use this for the scenario that we've got here, where we've got a single frequency extender on port 1 and a single one on port 2. If we were to be using 2 frequency extenders on the one side and a dual probe, we would use a 13 centimeter version of this cable instead. We got the 10 centimeter version. So there's a couple of ways you can do this. So one way you can do, which is what I'm going to do right here, is I've left the cap on this end, and I can just push this. You see this end? This is the end with a nut. This is the end that's just going to go in the probe. This end here is the female end, and this is going to go into the frequency extender. frequency extender has currently got which you probably can't see, has got a cap on it right there. So I can actually just go, give it a little twist and just push it straight through the rubber like that. Just going to point it upwards slightly. I'm going to take my cap off the end of the cable. I'm going to just sort of roughly place it inside like that. I'm going to take the cap off this end and put those caps back in the box. So that way, what I'm going to do is I'm going to mate it on the frequency extender end first. I like to do it on this end first because the port's really expensive on the frequency extender, and I don't want to be constrained or anything like that and have it move sideways. So I tend to do this end first. It doesn't, to be honest, doesn't particularly matter. And then what I generally do is with one finger underneath the extender, I'll slide it inwards and then I will put it onto the probe end. Probe end's a little bit less expensive. So as I said before, there's two ways of doing it. I definitely want to have a cap on the cable because I don't want it pushing through this rubber and get any rubber inside my connector. They're really small and you don't want to do that at all. Conventionally I just push this straight through like that. The other way you can do it, if you want to, is you can undo this and then you could push that to one side, then push that through. Making sure I've got it inside properly. Yeah, it's inside properly. And you could kind of do it this way if you have lost the cap or something like that. Or if you're worried about dropping the cap into the microchamber. So I push this down roughly towards where the probe is, not touching, just in the right general area. It's held by the rubber, it's not going to fall anywhere. And so those are ready to go. This system wouldn't be very much good unless you've got a frequency extender to make some measurements with. And what we're going to do is we're going to put this bracket onto the underside of here. The purpose of this bracket's got an open end to it. The idea of it is we can drop the bracket straight onto the mount with the head in place, and we can slide it backwards and forwards. Typically we'll start off with it, let's try in this position, like here, so it's far back. And then we can slide it forwards, so then we can ease the cable onto the probe. Or if you chose to, the extender onto the cable. But my preference is generally do this one with my fingers onto the extender, and then do this one by sliding the extender and cable forwards. Now, when we come to put the bracket on here, obviously it's really tempting to get this guy and just to flip it over like that. At the moment, the orientation of this cable is all nicely set up. What I don't really want to do is I don't really want to put a torque on this cable. For ease of access and ease of filming, what I'm going to do is I'm just going to take, on this frequency extender, I'm going to take this off the VNA. In general, we tend to avoid it being off for too long because it cools down and can drift, but it's when you're filming, we don't want to drop the frequency extender or do anything silly. Before I remove anything, what I'm just going to do is power it down. If I press that, you can see it's gone to sleep and it's changed color, it's gone to yellow. These screws that hold the connector for the frequency extender in place will fit a torque wrench, and so typically I always torque these up. I also make sure that I have it pushed in nice and straight. I don't want anything pulling to one side. They're kind of stiff. And just try to undo the screws evenly. You shouldn't need to use a torque wrench all the way out. Generally, it's a way of telling you that something is crooked. Before you remove it, just grab the frequency extender in case the action of moving it pulls it off the side or anything silly like that. So keep hold of this so you don't want this to hit anything or get any contaminants inside it or anything like that. So I'm going to take this and go to the bench. Let's put in fact we'll use the platen on the prober, that's pretty good. So I can put this on its back. Always holding the extender just in case it tries to sideways. I just pushed it in. You can feel them engaging the holes. Always have a hand on it just in case it falls off. As normal with any such things, leave them all close to tight but not quite tight. Just bias it slightly and then we'll just tighten them all up. So as I'm standing here right now, what I'll do is I'll go and put it on the positioner, making sure I know where the end of the cable is. Because it gets in the way a little bit, I'm going to take the cap off. Obviously you need to make sure that you don't poke anything in the end of it when you do so. Be careful. And I'm going to just put that over the top of there. Put the cable down there, making sure it can't touch anything. And so I'm going to get it so that I can just lock it in place like that. So it's not going to go anywhere. There's one on both sides, but one of them generally will suffice when you're just going in. Let me just see if I can get this roughly correct. So yeah, that's locked in position. What I'm going to do whilst I'm here, I'm going to get the torque wrench. The torque wrench that you need for this frequency extender is different to what you may be used to. So if you have had an instrument like an N5291 or an 8510XF for other instruments, you will be used to a torque wrench like this one here, which is 5 pound-inch, but has this very small head. I think that's 6mm across there. What you will be using with this frequency extender is just for the extender end only. The probe end still takes this one, the small one, but for the frequency extender you'll have same torque, 4 inch-pound, but it has a 14mm spanner size across it. So you will need to have one of these. I got this one from the Keysight Cal kit, and generally if you've got your instrument as a kit it will come with one of these, but you do need one to properly set the instrument up. The other thing I've got here is a spanner for anti-rotation, and this one says it's 5/32. This is to go on the flat of the cable just here. So I'm going to just get the cable, making sure it's clear of the probe. Nice and straight. It's generally go towards most of the way to the top. I'm just going to push it. I'm going to hold it down. And I'm going to just push that in nicely like that. I'm going to get the torque wrench. Don't forget my spanner in there. And just torque the cable end up. I'm going to put one finger or a couple of fingers underneath the frequency extender. Make sure you do this because it wants to slide forwards. I'm going to slacken both of these locking brackets, turnbuckles or whatever they're called. And so now the frequency extender is free. I can now, if you can see, slide it nice and straight down here. Now just gently guide it into the connector, and hopefully you can see me. I'm just tightening this up by fingers and just letting the tension of it pull. Just pull my fingers gently forwards. Just give it a little bit further extra. Just put under a tiny bit of compression because the nut will go in a tiny bit. I get my small 1mm torque wrench, and I'm going to get my anti-rotation wrench. It won't rotate anymore. Yeah, the tension on the cable is stopping it from rotating. That's all nicely torqued up now. Ideally, we should use a wrench to prevent rotation at each end. It's never a bad idea, once you've done the probe up, just to do a little quick double check on the top end. Ideally, you should always try to keep your finger behind the ring at the rear of the torque wrench. So that's that probe, that's all being torqued up, and now we'll do the same thing on the other side. Okay, so that's locked in place. So the same thing as we did with the other side. We get the cable, so it comes in nice and straight. So similarly, grab the frequency extender, lock it off, and we'll tighten it up. Okay, so we now have, I'm just going to lock these off, and I'll put my connection back on up here. I'll push it nice and straight. Make sure it's turned off still. This should go pretty much all the way in by hand. And the last bit, we'll just use a regular torque wrench, making sure that we alternate torque it. We don't want it pulling all one way. Sometimes it helps to push it in by hand slightly. It's important that these are in properly, they can drift otherwise. And I'm going to turn it back on again. And we're back and enabled again. Seeing as we have a bunch of top hat parts, let's go and fit all that stuff back up. First, before I put all these panels on, I'm going to put the top of the top hat on. The reason is that this basically sits underneath the rest of those. So I'll put that in place. We'll use a 2.5mm Allen key. These are, I think, M3 screws. Okay. And then we can put the window on the front. Screw these ones down on the sides. And on the black, we have a blanking plate. And there we have it. One last thing to do. So for autonomous, typically I am using a 10x objective for probes like 50 micron, 100 micron. I'm typically using a 10x. A 20x is very good also, but can sometimes be a little bit awkward because the working distance is quite short. The one point is, if you are using 250 micron probes, you must use a 20x objective. It's down to the fields of view of the E-view and basically the pixel resolution that you get, but the best combination we find for that is to use a 20x objective, so you just need to be a little bit more careful with your objective placement. The microscope that we have on this system, just to talk very briefly about that, is an E-view 4 microscope. This is the latest incarnation of E-view, and what does that do for us? It does a few things. One thing which is particularly useful for autonomous is that the focus transport is very fast. It uses quite an unconventional means for the focus transport, which means it doesn't have a lead screw and it can move very, very quickly. This is good because we do a lot of focuses. That isn't to say that things are bad using an E-view 3. E-view 3 is a perfectly good solution, but just the E-view 4 is typically my preference, just because of speed. The other thing which is good about it is the E-view 4 has crash protection, so it will retract the objective. And in the case of an elite prober or a CM300, those probers will, the scope transport, the actual lift is a motor, so it will stop that motor on the way down if it detects a crash for the E-view. It's very convenient. That crash protection is done in conjunction with these terminals that you see here. So if these terminals lift off their seat, then the system will detect that and use that as a means of detecting the crash, by which it will retract the mechanism inwards. One other advantage of this particular microscope is the E-view 3 had a focus range of 2 millimeters. This has a range of 4. So it allows a little bit more leniency on where you placed it. But as I say, E-view 3 works perfectly well, and we have customers using it today for this purpose. But E-view 4 is the later model. Okay, before I put the objective inside, I'm just going to get the objective sealing ring. And put it between the objective and the mount. And then seal the objective in. So what I'm just doing at the moment is I've just moved to the contact height that I had set beforehand. Contact height, you have to be quite careful, certainly on a Summit 200, because the movement range is very large. It's, currently my contact height is set to 42 millimeters. So you want to make sure that it is in the right general range, that there's going to be nothing unexpected. And I had my microscope set up for that height previously, so I'm happy to do that. But be very careful if you've come to machine totally cold. If you have, then one approach that you can do is to raise up, make sure that the microscope is really high. So if you're not sure, you can raise it up, and then you can take it down. And then I can take it down slowly. So then I can take it down very slowly, making sure I'm not going to touch my objective. I can go around and then open spectrum so I can see what I'm doing. In this case, let's maximize that. Now I don't have an ISS on there at the moment, so I'm not really going to be too worried about focusing it, though. I can take it down. Looks like I can see something just inside there, so that's about the right point.
So now that concludes the mechanical setup of the station.